Ignition sequence start.
Good morning, and welcome to this view of the International Space Station Flight Control Room, where the Orbit 2 team of flight controllers is on console, monitoring the operation of space station systems and working with the Expedition 65 crew members on their tasks to wrap up this segment of the ongoing mission of exploration. Commander Thomas Pesquet and his American, Russian, and Japanese crewmates are looking ahead to a Soyuz undocking this weekend that will leave 7 men and women on board the station to begin the work of Expedition 66.
Houston Station on Space to Ground.
Welcome to Space to Ground. I'm Leah Cheshire Mustachio. 3 Russian space explorers are preparing for their return to Earth. On October 16th, Russian cosmonaut Oleg Novitsky will command the Soyuz spacecraft carrying Russian actress Yulia Perslin and producer Klim Shipenko as it undocks from the space station. Novitsky's mission will conclude after 191 days, bringing him to a career total of 531 days in space over 3 flights. Spaceflight participants Perslin and Shipenko returned to Earth with 12 days in space, during which they filmed portions of an upcoming movie titled Challenge. The trio will parachute to a landing on the steppe of Kazakhstan at approximately 12:36 a.m. Eastern Time on October 17th. You can watch farewells, undocking, and landing live on NASA TV, the agency's website, and the NASA app. The space station crew is preparing for 1 Russian cargo ship to relocate and for another to arrive. On October 20th, the Progress 78 resupply ship will undock from the Poisk module, but its mission isn't over yet. Just over 24 hours later, it will redock to the Nauka module. A few days later, the Progress 79 resupply craft will dock to the Zvezda module after it launches on October 27th. NASA TV will provide live coverage of the Progress 78 redocking and Progress 79 launch. 3 CubeSats developed by students were shot into space this week. Students from the Universidad Interamericana de Puerto Rico, University of Illinois Urbana-Champaign, and University of Michigan developed 3 separate CubeSats to be launched from the International Space Station. These breadbox-sized payloads were deployed using the NanoRacks CubeSat deployer and will conduct research before disintegrating upon re-entry into the Earth's atmosphere. Through these CubeSats, students will study the practicality of communicating at high data rates, how particles stick, rebound, or fragment based on their mass and composition, how to improve thermal control on future CubeSats, and potential radiation mitigation techniques. That's all for today on Space to Ground. We'll see you next week.
The Soyuz spacecraft about to depart the International Space Station is the same one that delivered NASA astronaut Mark Vande Hei this past April for his second long-duration spaceflight. But he's staying on the station now for what is expected to become the longest single spaceflight ever by an American astronaut. Before he launched earlier this year, knowing that there was a chance he'd be making an extended trip, the retired U.S. Army colonel was looking forward to another shot at some of the things he knew he was going to get to experience once again.
So, arriving at the space station, something I'll never forget is looking over my left shoulder out the window in the Soyuz, where it was either a view of the Earth or blackness of space. And then all of a sudden I could see a solar array. Getting chills even thinking about it right now. It was this beautiful gold, massive. I mean, you don't ever train and see a solar array at full scale here. And so there it was, and the Russian commander sitting to my right. I had to really pay close attention, and I was supposed to be too. But as soon as I saw those solar rays, I broke the silence and said, "Wow!" And he was like, yeah, I was definitely a rookie. I was excited. The freedom of motion inside of the space station is huge. And then working was busy. It was definitely very busy. I got up there when a SpaceX Dragon spacecraft was docked, just because there's a lot of science that requires return and things have to be done in a very specific timeline. It was very fast-paced immediately. And the space station is very unique because on the space station, orbit is really a continuous free fall. And because of that, you can have some very unstable structures that might not be able to stay together if you're on the ground. They can stay together on the space station. Flames behave differently because combustion on the ground requires drawing in all these rich gases into the flame because the hot combustion gases go up and away. But there's no up and away on the space station. All directions are equal as far as that's concerned. So that behaves differently. There's all kinds of different phenomena that we can experiment with. That's why it's a wonderful laboratory. Many, many different experiments. Some of those experiments actually have to do with us as the test subjects because we're trying to understand how to have people safely travel for longer and longer distances too. That's just a sub-part of all the science we're doing on the space station. Some people have talked about at some point in the expedition feeling like it's time to go home, but for me there was always another spacewalk or another vehicle capture that was coming up, so it always felt like suddenly I was going home, and it surprised me. I'm Mark Vandehei, and I'm a NASA astronaut.
The people who strap themselves onto rockets and go to space are one example of the kinds of heroes who work at NASA. Along with the astronauts who leave the planet, there are many thousands of other people hard at work solving the challenges facing the space missions of today and those of tomorrow.
So you want to go to Mars. What does it take to be a NASA hero? Meet the heroes behind the scenes who make deep space exploration possible. People often think of astronauts as heroes, and they are. And they will be the first ones to tell you that there are many other people who make space missions successful. On Earth, there's ground support, the folks responsible for launch and landing. Heroes work in mission control and keep a watchful eye on the astronauts and spacecraft 24/7. Heroes design, test, build, and fly the rockets and spacecraft that take astronauts off our planet. And there are heroes who make spacesuits, habitats, and equipment for the astronauts to live and work on the Moon and Mars. Human spaceflight is possible because of the heroes on the ground and behind the scenes who build the technology and systems needed to send astronauts into the solar system. Will you be a NASA hero? For more information, visit this NASA website.
International Space Station science research is teaching humans more of what we need to know to be able to explore out beyond Earth orbit. For example, biomining could offer a way for crews to obtain needed materials on other planetary bodies. But microbes and rocks interact differently outside of Earth's gravity than they do here, and that might affect the output from extraterrestrial biomining. So there's an investigation on the station now studying how microbes grow on and how they alter planetary rocks.
The International Space Station will soon host some of the smallest miners in the universe, microbes. Microbes growing on the surface of rocks can gradually break them down and extract useful minerals and metals. This is a process called biomining. As we explore space, we are seeking to use biomining to turn rock and regolith into soil for growing plants and food. But before we can use this technique in planetary settlements, we first need to test it in space. On the space station, bioreactors will be placed inside a centrifuge where microbes will grow on rocks in microgravity and simulated Martian gravity. Investigators will examine how 3 types of microbes behave within pieces of basalt and evaluate how well the different microbes extract elements from the rocks. The findings will be compared to ground-based results. We hope to gain insights into how microbes interact with rocks in microgravity and how we might use them in our exploration of deep space.
One area of research being conducted on board the International Space Station is science that teaches us how to make those future long-duration missions safe and successful journeys for the human explorers. And that comes from learning how the human body reacts during prolonged exposure to the space environment. We're also looking into how we can provide the supplies that explorers will need on missions to deep space that will last for years. Supplies such as fresh food.
Space gardening. Presented by Science at NASA. Roman statesman Marcus Tullius Cicero said, "If you have a garden and a library, you have everything you need." Humans attempting someday to make Mars their home may well share the sentiments expressed by the orator from ancient Rome. As for the library, books can now be stored digitally. But how does your garden grow in space? To find out, scientists have been studying plant growth on the International Space Station, or ISS. The results could help boost the productivity of both extraterrestrial and earthly gardens. Recently, the ISS has been home to some impressive harvests, yielding tasty snacks for crew members. However, scientists aren't through trying to unlock the secrets of how plants grow away from home. Future space outpost dwellers will need to grow plants for food and for recycling air and water, says Annalisa Paul of the University of Florida. So we're studying how plants adapt to the spaceflight environment. Our findings will also help us understand how plants might respond to new and challenging environments here on Earth. Paul and her colleague Robert Furl have been growing plants in space since 1999, when they launched their first experiment on Space Shuttle Columbia. Several space station experiments followed. One of their most compelling discoveries was that certain root growth strategies assumed to require gravity really don't. Plant roots seek water and nutrients by growing away from where they're planted. To determine which direction to grow, terrestrial plants use gravity as a cue, and they use touch to maneuver around obstacles. In the late 1800s, Charles Darwin demonstrated that plants growing along a tilted surface don't send their roots directly away from the seed, but instead send them to the right or left. He hypothesized that this growing pattern, called skewing, was caused by a combination of the roots touching their way across the slanted surface and gravity pulling straight down on them. In an experiment in 2010, Paul and Furl discovered, however, that roots of plants growing in microgravity on the station skewed like their earthly counterparts. The ISS showed us something we never would have known otherwise, notes Paul. Gravity isn't essential in root orientation. Good news. That's one less impediment to growing plants in space. Plants will efficiently seek the nutrients they need without gravity as a cue. The experiment also studied the patterns of genetic expression. Space plants changed the way they expressed their genes in order to produce specific proteins helpful in zero gravity. Paul explains, when living organisms are faced with environmental change, their response almost always involves a change in genetic expression. To cope, they switch on and off certain genes. Plants are pros at this. Paul says, plants' cell walls undergo a kind of remodeling in space. The genes associated with a cell wall are often in the opposite switch positions than they're in on Earth. The researchers aren't yet sure what purpose this serves, but they intend to find out with additional experiments. Paul and Furl aren't alone. Many other scientists have also been studying plant growth on the space station to unlock the secrets of successfully growing plants in this novel environment. At the heart of all the research is the quest to provide humans with everything they need, wherever they may be. For more about gardening in space, visit www.nasa.gov/station. For more on the growth of science both on and off our home planet, visit science.nasa.gov.
The things we're learning on the International Space Station are helping us get ready for the next steps in human space exploration. NASA's Artemis program will return astronauts to the Moon as a step in the plan to send people to Mars in the years to come. NASA's Human Research Program is doing research and technology development on ways to enable people to live and work safely and effectively in space over long periods of time. One of the most challenging aspects of sending human beings out beyond low Earth orbit is dealing with space radiation.
For the journey to Mars, the Human Research Program works to project, assess, and solve the problems that astronauts have in space. Specifically for radiation research, the Human Research Program works to predict and mitigate the health effects of space radiation on astronauts.
I think one of the most challenging parts for the journey to Mars in terms of the humans and not necessarily the technology to get there is the risk of radiation exposure and the in-flight consequences of the exposure to radiation as well as the long-term health consequences of exposure.
There's two parts of radiation we have to protect the crew from. One is a solar particle event, where there's a solar storm and these energetic particles stream out. Fortunately, we know how to protect the crew from that. We put them into a shelter that's shielded by lots of water. And actually, they're very short duration, hours to days at most. They can come out and continue with their journey. That's the one aspect of radiation we know how to protect against. The other, which we really don't have a firm handle on, is galactic, cosmic rays. These are highly energetic particles that come from all over the galaxy towards the solar system and Earth. You can't shield against these. They're so energetic, they rip right through all metals, all plastic, all water, and all cellular material. And as they rip through these materials, little electrons and protons pull off of them, and you end up getting a cascade effect of radiation throughout the materials. And sometimes going through certain materials causes a worse radiation environment for the crew than had it gone through other materials. So we try to design the spacecraft out of materials that shield the crew from these, but also do not produce more hazardous particles as a function of being impacted with it. So a lot of people think that radiation will keep NASA from sending people to Mars, and that's not what the current situation is. We have techniques, we've discussed ways of getting there faster. We know that we add these various mitigations up, that we can have a successful Mars mission, a healthy crew, and have them live a very long and productive life after their return to Earth.
Experiments being done on the International Space Station cover many scientific disciplines, including medical science that could benefit the more than 5 million people on Earth who suffer from Parkinson's disease. When Alexander Gerst of the European Space Agency worked on an experiment with a certain protein crystal that could hold some important insights, NASA astronaut Serena Auñón-Chancellor walked us through what that was like.
Welcome to Expedition 57 on board the International Space Station. Today we're doing some really cool science. This is Alex Gerst over here with me, and we are working on Parkinson's disease. What we're looking at here is a special protein kinase, or protein crystal structure. And the reason scientists have sent it up here to the International Space Station is because these protein crystals tend to grow larger and of much better quality. Parkinson's is a disease that affects over 5 million people worldwide, and scientists are constantly searching for a cure. And what we discovered was that here in the microgravity environment, these crystals really like to grow. So if scientists can better elucidate or clarify the structure, then they're better able to develop an inhibitor drug for Parkinson's. And not only an inhibitor drug, but an inhibitor drug with very few side effects. So what Alex is doing here today is he's obviously working on the wall, is what it seems like here in microgravity, and he is. He's got a microscope above him, and he's got a plate that he filled with this special protein crystal structure just a few days ago. gave time for those structures to crystallize, and now he's examining them under the microscope. And he's actually interacting real time with the principal investigator on the ground to look at the crystal structure, to help improve the lighting and the clarity, and then also take pictures, which will then be sent back down to the ground. So here on board Expedition 57, we're very proud to be taking part in this experiment. I think in the past few years, scientists have realized that the microgravity environment is such a unique environment to grow things like cells or protein crystals, and it provides a new way to help us look at diseases in a better way, to help us develop new medications for these diseases, and so we're happy to be taking part in the science up here.
Along with assisting with experiments in microgravity and the occasional robotic arm operation and spacewalk, and of course the ubiquitous other duties as assigned, astronauts on the International Space Station devote some of their time to helping students who are studying science, technology, engineering, and math. In this demonstration video, astronaut Ricky Arnold shows us how the molecules that make up water behave in space.
Welcome to the International Space Station. I'm NASA astronaut Ricky Arnold. Our view from the ISS of Earth is absolutely magnificent, but we quickly realized we really should call it Planet Ocean. We are mostly a water planet. Water occurs here in all three phases, solid, liquid, and gas. And the presence of water on other planets and moons within our own solar system has us wondering, is there life there too? Well, why is water so special? One reason is called surface tension. So what is surface tension? Let's have a look. Surface tension is a property of liquids in which molecules of one substance are more attracted to each other than to molecules of another substance. Water is unique in that it has a high surface tension compared to other liquids. This is due to its polar property. The positive hydrogen ends and the negative oxygen ends create a strong bond. As they say, opposites attract. So the hydrogen end of the water tends to stick to the oxygen end in a nearby water molecule. At water's surface, its molecules are only attracted to the water molecules below and to the sides of them, as there is only air above these molecules. So the surface molecules of a body of water are pulled down, creating a more stable, stronger environment. That is why certain animals, like the water strider, can actually walk on the surface of water. Here on the International Space Station, the microgravity environment makes it easy to show how well water uses surface tension to stick together. We even rely on surface tension to help us wash our hair, those of us that have a lot. Thanks for coming along today and learning a little bit about surface tension. Want to learn more about the unique properties of water and do your own experiments? Try out the activity related to this video at the STEMonstrations website. See you next time.
People from 19 countries have been aboard the International Space Station in more than 20 years of continuous human habitation. Hazza al-Mansouri of the United Arab Emirates was there in 2019 and says he has a new perspective on the power created when the nations of the world work together in space.
Recently, our country opened this opportunity to participate in a space program and to be part of international cooperation, to be part of the ISS. So I applied, and then through my journey I've been selected, and I've been fortunate to represent my country and also the whole Arab region, because I will be the first Arab on board the station. I read about Yuri Gagarin and Neil Armstrong, how they achieved their dreams and how they really reach the moon at that era. And then all of these things started the passion in me that I want to be part of this. I want to reach beyond the sky, to reach stars. Sitting at the top of the rocket and waiting for countdown, going to stars, and to join a lead team on board the station, doing science, doing something for humanity. It's really something incredible, something that you want to tell it to the next generation. If you ask me like 2 years ago, can you be an astronaut? I will tell you I would like to be, but I think it's impossible. But now it's possible. What we did in our country and in our region after this mission is really impressive in terms of igniting the spark in the next generation. This is our job as an astronaut to let them know, to give them the experience that what we saw, what we experienced on board the station. You cannot experience here on Earth, from microgravity, from floating, and the view of the Earth from there. It's really amazing. It's something that's overwhelming. Looking at Earth from that angle, it's different angle, different perspective, and you come back with appreciation what you have here on ground. I landed in Kazakhstan, but I felt like I'm back home. So despite the country that you land, you come back to your home, to our mothership, to our planet, to Earth. It's amazing how space unites everyone, despite from which country you're coming from, or from your religion or your background. It unites everyone. So it's really important to focus in this aspect and to focus in this front to exploring space, because somehow everything is dissolved. All these political issues, all borders dissolve. Despite from where we are coming, like from which country, our backgrounds, our religion, our objective is one, is for humankind.
If you'd like another look at any of these stories, navigate over to YouTube and Facebook. You'll find them all there, along with lots of other great features on a wide variety of NASA topics. And if you're looking for good conversation about human spaceflight, check out Houston, We Have a Podcast, our weekly show about all aspects of human spaceflight and NASA's missions of exploration. Today, Gary Jordan gets some insight into the science agenda of International Space Station Commander Thomas Pesquet, the current point man for European Space Agency-sponsored Science on Orbit, in a chat with an ESA scientist. Go to nasa.gov/podcasts for this week's episode, all the previous episodes too, and the full library of all the NASA podcasts, which are also on Apple Podcasts, Google Podcasts, and SoundCloud.